Okay, so we're back to check our answers to the chart. So if you have any questions about how I'm going to get these answers on the chart, make sure you either go back to look at how we did the first row or email me to get a little more clarification. Okay, so here are the answers. So for 10 miles per hour, that's the same as 14.67 feet per second. So you can see that this doubled, this is also going to double, right? I'm going a distance. However I measure that distance, the distance doubled. Or the speed, I should say. 20 miles per hour is the same as 29.33 feet per second. 40 miles per hour is 58.67 feet per second. So to go from the first column to the second column, I used this conversion. Now, once I had my second column, I substitute that in for V sub 0. I square it, I divide by 54 and 74 hundredths, and that's where I get this. Okay, so when I was going 5 miles per hour, it took me a little less than 1 foot to stop. From the time I hit the brake, that's how much farther I kept going before my car stopped. If I'm going 10 miles per hour, I go 3.93 feet further, almost 4 feet. If I'm going 20 miles per hour, I go almost 16 feet. And if I'm going 40 miles per hour, I go almost 63 feet. Okay, so our question was, when I double my speed, how does that affect the braking distance? So to make this a little bit simpler, let's round these braking distances. So this is about 1 foot. This is about 4 feet. This is about 16 feet. This one might seem weird, but I'm going to call it about 64 feet, which it is, right? It rounds to 63, but I'm going to call it 64. So when my speed doubles from 5 to 10, does my braking distance double also? Hopefully you can clearly say no, it does not. So what happens is this. When my speed or velocity, right, doubles, the braking distance does what? What happens to that? So here this doubled. How many times bigger is this? Or you can look at 10 to 20. 10 to 20 doubles. How many times bigger is this? Or 20 to 40 doubles. How many times bigger is that? Hopefully you see, you could either say it quadruples, right? Quadruple means times 4. Or you could say the braking distance is 4 times larger. Not 4 feet larger, right? But 4 times larger. Either way. So my speed doubled, my braking distance got 4 times as big. So I'm going 40 miles an hour. I mean, that's not like, speeding. And it takes me 64 feet to stop. And that's with a relatively good coefficient of friction. So reasonable tires, reasonable roadway, reasonable conditions, right? So imagine now 40 miles an hour on an icy road, or you have bad tires, or on gravel, or whatever, okay? So my question also now is, why is this? How come when my speed doubles, my distance doesn't just double? How come my speed doubles and my braking distance is 4 times as big? What do you see in the formula that does that? So in here. So hopefully you're noticing it's going to have something to do with that squared. Okay, so let me show you what happens there. Let's just call a speed x, right? We know we're okay with variables, right? So we're going to call our speed x. We don't know which value it is from our chart. We're just going to call it x. And I square x. So x squared, right? Or another way I can say that is x times x is just going to give me x squared. That's what squaring means. Multiply it by itself. Okay. Now let's say I have a new speed. And my new speed is twice as big as this one. So it's going to be 2 times x, right? Like if I have my first speed is 8, my doubled speed is 2 times 8, or 16. So now I'm going to square that. Squaring means to multiply it by itself. Well, my x times my x is going to give me x squared, but I don't have 2 here. I have 2 times 2, which is going to be 4. So here was my first distance. Here's my second distance. 4 times x squared. Okay, because that doubling, that times 2 from here gets squared to be times 4 here. If I had, let's say I have my initial speed, and then instead of doubling that speed, I triple that speed. So let's pretend I had gotten 15 here. Well, if I square something that's 3 times as big, can you see how many times bigger that's going to be? Not 6, right? But 9. So if I triple something, it's going to be 9 times as big once I square it. So change in speed. If you're going faster, that makes a much larger difference than you would think in the braking distance. Okay, so this is all for lesson 3.4. It was actually a relatively short lesson. We're not doing 3.5, so don't panic when you don't see that on the homework. And next week we will do 3.6, 3.7, and start reviewing for the next test. Okay, also your test grades are up on Carnegie website, so go ahead and make sure you look at those. Okay, all right, email me with any questions. Bye guys.